By using the Database Resource Manager, also called the Resource Manager, you have more control over the allocation of machine resources than is normally possible through operating system resource management alone. If resource management decisions are made by the operating system, it can lead to problems such as excessive overhead resulting from operating system context switching of Oracle database server processes when the number of server processes is high, suspension of a database server process that is holding a latch, unequal distribution of resources among all Oracle database processes, and an inability to prioritize one task over another. Inability to manage database-specific resources, such as parallel execution servers and active sessions. Administering systems by using the Database Resource Manager involves the use of resource plans, resource consumer groups, and resource plan directives. A resource consumer group defines a set of users or sessions that have similar requirements for using system and database resources. A resource plan specifies how the resources are distributed among various resource consumer groups. The Database Resource Manager also allows for creation of plans within plans, called subplans. Resource plan directives specify how a particular resource is shared among consumer groups or subplans. You associate resource consumer groups and subplans with a particular resource plan through plan directives. Resource allocation methods determine what policy to use when allocating for any particular resource. Resource allocation methods are used by resource plans and resource consumer groups. The Database Resource Manager provides several means of allocating resources. CPU method enables you to specify how CPU resources are allocated among consumer groups and subplans. Degree of parallelism limit enables you to control the maximum degree of parallelism for any operation within a consumer group. Active session pool with queuing allows you to limit the number of concurrent active sessions for a consumer group or subplan. Undo pool enables you to control the total amount of undo that can be generated by a consumer group or subplan. Execution time limit allows you to specify a maximum execution time allowed for an operation. Idle time limit enables you to specify an amount of time for which a session can be idle, after which it will be terminated. Max_idle_ time. Consumer group switching specifies conditions that will cause a session to switch consumer groups. Typically, overuse of a resource is specified and a session is switched to a more restrictive consumer group. Database consolidation. The Resource Manager enables you to optimize resource allocation among concurrent database sessions. Server consolidation. Because many test, development and small production databases are unable to fully utilize the servers that they are on, server consolidation provides a possible alternative. With server consolidation, resources are more fully utilized by running multiple database instances on the server. You can access resource plans with the graphical interface of Enterprise Manager Cloud Control or the command line of the DBMS_resource_manager package. The automated maintenance tasks rely on the Resource Manager being enabled during the maintenance windows. When a maintenance window opens, the default _maintenance_plan Resource Manager plan is automatically set to control the amount of CPU that is used by the automated maintenance tasks. To be able to give different priorities to each possible task during a maintenance window, various consumer groups are assigned to default _maintenance_plan. The default _plan resource plan is one of the default plans provided for you. It contains directives for the following provided consumer groups. SYS group, the initial consumer group for the SYS and system users. Other _groups, used for all sessions that belong to consumer groups that are not part of the active resource plan. There must be a plan directive for other _groups in any active plan. Or a $auto task, a group with lower priority than SYS_group and other _groups in this plan. The initial consumer group of a user is the consumer group to which any session created by that user initially belongs. If you have not set the initial consumer group for a user, the user's initial consumer group will automatically be default _consumer_ group. The default _plan and associated resource consumer groups can be used or not used. It can be a template for new resource plans. It can be modified or deleted. Use it as appropriate for your environment. You can create a simple resource plan by using the DBMS_resource_manager. Create _simple_ plan procedure. You can create consumer groups and allocate resources to them by using this single procedure. The create _simple_ plan procedure accepts the following arguments. Simple_ plan, name of the plan. Consumer _group 1, through consumer_group 8, consumer group names, group 1_%, through group 8_%, CPU resource allocated to the groups. The plan uses the default CPU allocation policy. The plan uses the default CPU allocation policy, emphasis. Each consumer group uses the default scheduling policy, round_robin. The consumer groups specified in the plan are allocated CPU percentage at level 2 as shown in the table in the slide. The plan also includes the SYS_group consumer group and the other _groups consumer group. As shown in the table in the slide, SYS_group is allocated 100% of the CPU at level 1 and other _groups is allocated 100% of the CPU at level 3. You can perform the following steps by using the named procedures in the DBMS_resource_manager package or by using Enterprise Manager Cloud Control. 1. Create a pending area. 2. Create, modify, or delete consumer groups. 3. Map sessions to consumer groups. 4. Create the resource plan. 5. Create resource plan directives. 6. Validate the pending area. 7. Submit the pending area. In Enterprise Manager Cloud Control, there are several property pages that you can use to specify plan directives. 1. On the General page, associate consumer groups with plans and specify how much CPU each consumer group or subplan is allocated. 2. On the Parallelism page, specify a limit on the degree of parallelism for any operation issued by this consumer group, a limit on the total number of parallel server processes that can be used by all sessions in this consumer group, and the maximum time a parallel statement can be queued. 3. On the Thresholds page, specify the time duration or the resource limits under which a session can execute in a consumer group. 4. On the Idle Time page, specify an amount of time that a session can be idle, after which it will be terminated. You can further restrict such termination to only those sessions that are blocking other sessions. Resource allocation methods determine how the resource manager allocates a particular resource to a resource consumer group or resource plan. You specify values for the following resource allocation methods when creating the resource plan. There are two ways of specifying the CPU distribution with the MGMT_MTH parameter when you create a resource plan. Emphasis is the default method for single-level plans. It is also used for multi-level plans that use percentages to specify how CPU is distributed among consumer groups. Ratio is for single-level plans that use ratios to specify how CPU is distributed. Parallel_degree_limit_MTH limits the maximum degree of parallelism of any operation. This method can be specified only for resource consumer groups, not subplans. The parallel_degree_limit_absolute method is the only possible value, specifying how many processes may be assigned to an operation. If there are multiple plan directives referring to the same subplan or consumer group, the minimum of all the possible values is used as the parallel degree limit for that subplan or consumer group. The active_ses_pool_MTH parameter limits the number of active sessions. All other sessions are inactive and wait in a queue to be activated. The only available method for this parameter is active_ses_pool_absolute, which is its default value. Queuing_MTH controls the order in which queued inactive sessions execute. FIFO_timeout is the default and only method available. The CPU allocation method emphasis determines how much emphasis is given to sessions in different consumer groups in a resource plan. CPU usage is assigned levels from 1 through 8, with level 1 having the highest priority. Percentages specify how to allocate CPU to each consumer group at each level. The following rules apply for the emphasis resource allocation method. CPU resources are distributed at a given level on the basis of the specified percentages. The percentage of CPU specified for a resource consumer group is a maximum for how much that consumer group can use at a given level. Consumer resources that are not used at a given level are made available to consumer groups at the next level. For example, if the consumer groups at level 1 use only 60% of the available resources, the additional 40% is made available to consumer groups at level 2. The sum of percentages at any given level must be less than or equal to 100. Any levels that have no plan directives explicitly specified have a default of 0% for all subplans or consumer groups. The emphasis resource allocation method avoids starvation problems where resource allocation method avoids starvation problems, where consumers with lower priorities are not given the opportunity to run. The ratio policy is a single-level CPU allocation method. Instead of percentages, you specify numbers corresponding to the ratio of CPU you want to give to the consumer group. For example, given 3 consumer groups OLTP_users, DSS_users, and batch_users, you can specify the following ratios: OLTP_users, 4. DSS_users, 3. Batch_users, 2. Other, 1. This is similar to saying that OLTP users should get 40% of the resources, DSS users should get 30% of the resources, batch users should get 20% of the resources, and all other consumer groups should get 10% of the available resources. If there are no consumers in the other or DSS_users consumer groups currently utilizing CPU resources, the OLTP_users consumer group would get 2/3, 4 shares out of 6 shares, of the available resources, and the batch_users consumer group would get the other third, 2 shares out of 6. If all groups had sessions running, the division would be based on 10 shares. Using the Active Session Pool feature, you can control the maximum number of concurrently active sessions per resource consumer group. With this functionality, a DBA can indirectly control the amount of resources that any resource consumer group uses because resource copyright 2014, Oracle and/or its affiliates. All rights reserved. Consumption is proportional to the number of active sessions. Using an active session pool can help to reduce the number of servers taking resources in the system, thus avoiding inefficient paging, swapping, and other resource depletion, such as memory, resulting from attempting to run too many jobs simultaneously. Specifying execution time limit. Proactive estimation of the execution time for an operation, via cost-based optimizer statistics, default, unlimited. Specifying maximum estimated execution time at the resource consumer group level. Huge jobs will not be allowed to start if the estimate is longer than max_est_exec_time. ORA 07455. Specifying other thresholds. Limiting session I/O with SCOGS switch_IO_megabytes, in MB. Limiting session I/O requests with switch_IO_REQS. Returning to original consumer group with switch_for_call, default, false, consumer group is not restored. In Enterprise Manager Cloud Control, use the Idle Time tab to set the maximum idle timeouts for a resource plan. Max idle time, sec, and max idle time if blocking another session, sec, are the respective equivalents of the new_max_idle_time and new_max_idle_blocker_time resource directives in the DBMS_resource_manager. Update_plan_directive procedure. They are both specified in seconds. For concurrent database sessions, database consolidation requires that applications are isolated from each other. If one application experiences an increase in workload, that increase should not affect other applications. In addition, the performance of each application should be consistent. Fixed policy CPU resource management. The max_utilization_limit attribute of resource plan directives enables you to impose an absolute upper limit on CPU utilization for a resource consumer group. This absolute limit overrides any redistribution of CPU within a plan. The max_utilization_limit directive limits the CPU consumption of an application. You can set minimum and maximum boundaries, as shown in the slide. The place SQL example in the slide specifies a minimum value percentage, 50%, for the CPU allocation resource at level 1 for the app_1 consumer group. This example also specifies an absolute maximum CPU utilization percentage, 60%, permitted for that same consumer group. The example uses the DB_consolidation_plan. Similar commands can be executed for each consumer group shown in the sample tables. Because many test, development, and small production databases are unable to fully utilize the servers that they are on, server consolidation provides a possible alternative. With server consolidation, resources are more fully utilized by running multiple database instances on the server. However, this may bring about CPU contention and an adverse impact due to workload surges on one instance. Instance caging is a method that uses the CPU_count initialization parameter to limit the number of CPUs that an instance can use. In addition, the resource manager is employed to allocate the CPUs for the database sessions based on the instance resource plan. Over-provisioning approach. This approach is appropriate for non-critical databases and low-load, non-critical production systems. Although the instances impact each other's performance, at any given time, one or more of the instances may be idle or experiencing a low load. Partitioning approach. This approach is appropriate for critical product systems. It prevents the instances from interfering with each other and provides predictable performance. If the CPU_count parameter is not set, no value is returned by the first query. If no rows are returned by the second query in the slide, the resource manager is not managing the CPU. If a row is returned, it indicates the active plan. Instance caging limits the CPU consumption of the foreground processes by throttling them. A foreground process is throttled when it is waiting on the res_mgr CPU quantum wait event. You can monitor the amount of throttling in two ways. The $RSRCMGRMETRIC_history view shows the amount of CPU consumption, CPU_consumed_time, and throttling, CPU_wait_time, for each minute in the past hour. Values are displayed in milliseconds. The $RSRC_consumer_group view shows the amount of CPU consumption, CPU_consumed_time, and throttling, CPU_wait_time, since CPU resource management was enabled. The time is displayed in milliseconds. To better track runaway queries, Resource Manager included the following: parameters used to trigger consumer group switching, directive parameters, switch_IO_logical, switch_elapsed_time, meta consumer group called log_only, columns in $SQL_monitor, last_action, last_action_reason, last_action_time, consumer group, $RSRCMGRMETRIC and $RSRCMGRMETRIC_history always populated. You can configure the Database Resource Manager to automatically assign consumer groups to sessions by providing mappings between session attributes and consumer groups. Further, you can prioritize the mappings so as to indicate which mapping has precedence in case of conflicts. There are two types of session attributes: login attributes and runtime attributes. The login attributes are meaningful only at session login time, when the Database Resource Manager determines the initial consumer group of the session. In contrast, a session that has already logged in can later be reassigned to another consumer group on the basis of its runtime attributes. The plan for an instance is defined using the resource_manager_plan database initialization parameter. This parameter specifies the top plan to be used for this instance. If no plan is specified, the resource manager is not activated for the instance. You can activate, deactivate, or change the current top plan by using an alter system statement. When a resource plan is changed using this command, the change takes effect instantly. If the parameter is set in a parameter file, and the plan specified is not defined in the database cannot be opened with that parameter file. Several data dictionary views are available to check the resource plans, consumer groups, and plan directives that are declared in the instance. This section discusses some useful information that can be obtained from these views. For more detailed information about the contents of each of these views, refer to the Oracle Database Reference Manual. You can access Resource Manager statistics by selecting Performance Statistics on the Getting Started with Database Resource Manager page in Enterprise Manager Cloud Control. Information is provided so that you can monitor the currently enabled resource plan. There are at least 3 different views in the system that can provide you with information about the CPU utilization inside the Oracle database. $RSRC_consumer_group shows CPU utilization statistics on a per consumer group basis, if you are running the Oracle Database Resource Manager. This view displays data related to currently active resource consumer groups. $Systat shows the Oracle Database CPU usage for all sessions. The statistic, CPU used by this session, shows the aggregate CPU used by all sessions. $Sestat shows the Oracle Database CPU usage per session. You can use this view to determine which particular session is using the most CPU.